Hello everyone, this is Muhammad Mehkoom presenting here the third order nonlinear optical measurements and optical limiting response of a newly synthesized organic dye. Here let me start from the abstract. In present work, we evaluated the third order nonlinear optical parameters of this dye AF11 using the Z-scan method with a diode laser of 120 milliwatt at 520 nanometer. Here we use close aperture and open aperture Z-scan method for measurement of concentration dependent nonlinear refraction and nonlinear absorption. Now the introduction. The different organic and inorganic compounds have been designed for application in optoelectronic devices. The envelope properties of optical materials depends on different parameters like long pi bond conjugation and charge orientation, etc. In this context, our dye molecules include some above mentioned factors. Now experimental details. For NLO measurements, we use Z-scan technique, which is based on principle of spatial beam distortion. Further details of this method is available in reference number 3 and 4. Now the result and discussion. This is the structure of our dipyrrozole derivative, and this is the absorption profile. Here the peak absorption is found to be at 382 nanometer. Here this is the close aperture Z-scan normalized transmittance, and it is the open aperture Z-scan normalized transmittance. We recorded normalized transmittance for different concentration as well as various laser power. This close aperture graph show the peak value configuration. It is the effect of self-defocusing nature of the sample, and it is clear indication of negative nonlinear refraction, which is induced thermally nature of the dye. Further, this open aperture graph show the value of normalized transmittance at the focus, which is attributed to the reverse saturable absorption nature of the sample and indicates positive nonlinear absorption in the dye. In an indirect way, we can say that the N2 and beta are related to the normalized transmittance and phase shift, which are given in these equations. One can find out the NLO parameters by doing the theoretical fitting on normalized transmittance using these formulations. In this table 1, we calculated concentration dependent NLO parameter, the N2 and beta, and the third is third order nonlinear susceptibility. And in the table 2, we represent power dependent NLO parameters. Further, in figure 4 and 5, variation of N2 and beta show that as the concentration and laser power increase, the magnitude of N2 and beta also increased almost linearly. This variation established fact that for higher concentration, the more number of molecules get thermally excited by the absorption of laser radiation. So the sample behaves like a thermal lens and producing the temperature dependent refractive index. Hence the optical nonlinearity enhanced with increase of concentration as well as power. Furthermore, the optical limiting nature of the dye AF11 observed in terms of output and input power. We measured the optical limiting parameters for various concentrations. This graph 7 reveals that the optical limiting threshold and saturated power decrease with increase of concentration. So, this is due to the higher optical nonlinearity at higher concentration as well as at higher power. So, from the above results, we can say that our dye AF11 possesses good analog behavior as well as good optical limiting nature. So, here is the conclusion and the last is references. Thank you.